Welcome to Automotive Cybersecurity, Protecting the Vehicular Network, brought to you by IEEE Continuing Education and authored by Dr. Madhusudan Singh. This course will cover how using blockchain technology can secure autonomous vehicles. This course is developed by IEEE Educational Activities with the support from the IEEE Computer Society. IEEE strives to bring you training on cutting-edge topics presented by some of the world's leading subject matter experts. Be sure to check out all of the continuing education training for engineers from IEEE Continuing Education. Our courses are designed to help you excel in your career. Dr. Madhusudan Singh has conducted extensive research on autonomous vehicle technologies, specializing in cybersecurity. He has a background in artificial intelligence, machine-to-machine communication, wireless communication technologies, and software engineering. He is an expert on blockchain technologies as they can be applied in the field of cybersecurity. Welcome to Blockchain Technologies in Autonomous Vehicles. In this course, there are 5 major learning objectives grouped into 5 modules. We will dive deep in each module as we progress into the course. Let us first take a brief look at the objectives we will encounter in each module. Module 1 of this course will introduce you to blockchain technology and its automotive applications. Module 2 will cover blockchain technology solutions for autonomous vehicles. Module 3 will showcase applied scenarios for blockchain technology solutions and how they work. Module 4 will examine a scenario of blockchain-based intelligent vehicle intersection. And in our last module, Module 5, we will conduct a simulation analysis of applied blockchain technology solutions and show how decisions are made. Let's begin in Module 1 by introducing blockchain technology and its automotive applications. Let us begin to understand some of the basics of blockchain technology. Blockchain technology is basically a consensus of replicated, shared, and synchronized digital data that is geographically spread across multiple sites. So, one form of distributed ledger design is the blockchain system, which can either be public or private. A blockchain is a type of a digital distributed ledger. There is no central administrator or centralized data storage. We will explain when this technology emerged and its elements in the following slides. Blockchain technology emerged in late 2008 in the midst of a global financial crisis. Blockchain is by all means a distributive technology that is comprised of unchangeable, digitally recorded data in packages called blocks. These digitally recorded blocks of data are stored in a linear chain. Each block in the chain contains data that is cryptographically hashed. Next, we will examine the characteristics of this technology. To better understand blockchain technology, you must consider the distributed ledger technology is a parent technology of the blockchain. As a result, all blockchain technologies are indeed a type of distributed ledger, but not all distributed ledgers are blockchains. The architecture behind blockchain technology is a peer-to-peer network without the interference of a third party. How do these characteristics lend themselves to autonomous vehicles? Click Next to examine further. Clearly, there are several characteristics of blockchain technology that lend themselves to autonomous vehicles and their everyday use. During the introductory course in this program, we had explained how the automotive industry stems from a safety culture, while the information technology industry stems from a security culture. The pinnacle accomplishment of the merging of the two industries is the development of a safe autonomous vehicle that utilizes the security characteristics offered by blockchain. This promotes safety, which is the paramount prerequisite in the automotive industry. Let us examine further and compare the traditional security offered by the information technology industry as compared to the new blockchain solution. When comparing traditional security protection versus blockchain technology protection, there are numerous characteristics that we must explain in order to understand the true value that blockchain technology has to offer. Let us compare the two. Conventional security methods are incapable to provide secure communication for autonomous vehicles. The graph on the right shows in how many ways modern cars are vulnerable to hacking. But why does traditional security fail? First, traditional protection is based on a centralized architecture that does not apply itself to the required decentralized vehicular reality. For example, it does not offer peer-to-peer communication. Second, it requires a lot of resources in order to offer adequate protection. Such resources are encryption and decryption-enabled hardware. Third, it is very hard for traditional systems to protect data that is mobile or on the go, like in the case of vehicles that are moving. Fourth, they are unable to manage and protect large amounts of data being exchanged at the same time. Fifth, they do not have access to the history of each vehicle, and therefore there is no verification. And sixth, there is no distributed network. On the other hand, blockchain technology protection offers a secure, decentralized, distributed environment for vehicles. Blockchain technology protection is by definition a decentralized architecture that mimics the vehicular environment. Second, it is low on resources, since one blockchain server can manage the entire system. Third, it is able to protect data that is mobile because it is decentralized and resources are distributed throughout the vehicle communication environment. Fourth, it is able to handle large amounts of data at the same time because the data is stored in the blockchain server, which is distributed and not centralized. Fifth, it has access to vehicle history because of peer-to-peer real-time communication and that all the data is stored on the distributed blockchain server. Sixth, there's a distributed network since every node has its own database, meaning the databases and the same network data is shared in real time between the nodes. Now, despite all these advantages, there are still vulnerabilities in the blockchain paradigm that we will examine later. Let us examine more closely what are the relevant blockchain characteristics that are important to autonomous vehicle safety. In the blockchain paradigm, all parties must agree to network-verified transaction. Therefore, we have consensus. The system is what is called an append-only system of record that is shared across a business network. Therefore, we have a digitally distributed shared ledger. All the business terms are embedded in a transaction database and executed with transactions. Therefore, we have what is called a smart contract. Last, the blockchain paradigm ensures secure, authenticated, and verifiable transactions. Therefore, we have cryptography. To familiarize yourself better, click on any of the 4 relevant blockchain characteristics important to autonomous vehicle safety in the blockchain paradigm to see the definition and relevant example. Consensus means that all parties agree to network-verified transaction. This characteristic promotes trustability, liability, and authentication authorization. Having a distributed ledger means that the system will store all communication information data stored into the ledger. This is what is called an append-only system of record because it is stored and distributed across a network. This advantage provides data availability, the ability to retain all data, and traceability. Having cryptography means secure, authenticated, and verifiable transactions, which translates into confidentiality, data encryption, and integrity, since no modification can be made. In autonomous vehicles, we achieve this by using the hash ID. Having shared contract means that all terms are embedded in a transaction database and executed with transactions. This ensures a trust in the negotiation process and the final contract. Thanks to this, we have trustability and non-repudiation, which is the assurance that someone cannot deny something. Let us look at the overall blockchain communication environment. This graph represents what the blockchain network looks like specifically when designed for the vehicular communication environment. All vehicles in the network will be able to communicate with one another, and vehicles can communicate directly from vehicle to vehicle with complete privacy. The vehicles can communicate to the vehicular cloud and receive information about services. All vehicles share information with family or friends within the Wi-Fi infrastructure. All vehicular information is stored on the blockchain server in real time, and the data stored can be accessed anytime. In this module, we will begin to understand why the autonomous vehicle field is experiencing revolutionary growth in academic research and industry, but still suffers from security vulnerabilities. Let us discuss the push for blockchain technology solutions and why the motivation for autonomous vehicles is very strong. These solutions can increase the number of passengers traveling, the amount of goods shipped, and the average vehicle speed by a significant amount. At the same time, we will be able to decrease congestion, accidents, and crashes, and the overall carbon footprint. All the above can be accomplished by utilizing the same basic road and highway infrastructure. We will see next how this can be achieved. Let us examine how the process works. The autonomous-enabled blockchain vehicle on the left acts as the sender. The sender creates the transaction, symbolized here, as a block transaction distributed and validated via cryptographic hashing. After the verification, the information is stored on the blockchain servers. The same information is mirrored on all servers. All this is part of the vehicular cloud, in which data transmission is committed to blockchain and miners are rewarded by the senders. The vehicular cloud is a hybrid technology that uses vehicle resources, such as computing, data storage, and internet decision-making. The vehicular cloud is a hybrid technology that uses vehicle resources, such as computing, data storage, and internet decision-making. A miner is a blockchain-enabled vehicle that can validate the data transmission in the network. The receiver is confident that the information is accurate because it is coming from the blockchain server.